Now it's time for you guys to start reviewing magnetism, which you guys started last year in grade 11. That is way too thin. All right, we're going to start reviewing magnetism. And you guys took some basics about magnetism and properties of magnetism in grade 11. So let's review some of that stuff today and go over a few different things. Now, we looked at some of the similarities and differences between electric fields and magnetic fields last year. So, for example, if we compare to electric fields, you know, there's two polarities. That was one of the similarities. They can attract and they can repel, just like electric fields and electric forces can do. So there's two polarities, they attract and repel, that type of stuff. But there were some differences. Some of the differences include a few different things. One of the biggest difference is there's no single poles. So for electric fields, you can have a positive or negative by themselves, but in magnetism, typically you don't have single poles. And what we did last year is, remember, if we took a magnet, something like this, you had north end, you have a south end. Remember, standard color coding for magnetic fields is blue, and magnetic fields go from north and south. And we said if you break the magnet in half, you don't have a north end and a south end. There'll be a new south pole there, there'll be a new north pole there. And this connected to what you guys did with domains and that type of stuff. So these are some of the similarities and differences, how they look. Even with the differences for when you draw the magnetic fields, when you have two poles with electric fields, the electric fields, they look an awful lot like magnetic fields, but with electric fields, of course, you can have single poles, so you can have electric fields just going in or going out. But when you have magnetic fields, when you actually draw the actual fields themselves, they have to go in and out of the same object because there are no single poles. So that's a little bit different and stuff like that. So those are just some of the things that we looked at last year. But if we start looking at some other things, we already mentioned domains. So if you remember from grade 11, so these are those little tiny micromagnetic sections inside of material, and depending on how they line up and how they move, these guys are the ones that actually sort of determine sort of magnetic properties. And we even looked at different types of materials. For example, we looked at if something is ferromagnetic. Hope that sounds familiar. Remember, these are the ones with really, really, really loose domains, which means they move around really easy, like an iron. We also looked at ferromagnetic. We also looked at paramagnetic last year. So there's paramagnetic as well, and these guys have typically really tight domains. So they might try and move a little bit, but generally they're kind of rigid, so they're not really going anywhere. Okay, and then we also had the diamagnetic. Change that, get that G out of there. So we had diamagnetic as well, grade 11, and these are the ones, they're tight domains, but these guys always repel. So we sort of map things out a bit. You got the material, and we have, this we drew last year in grade 11. So inside the material, there's these little microscopic regions called domains, and if they line up really, really good, like in something ferromagnetic, then you have something really, really magnetic. It works really, really well like an iron. Paramagnetic, they might line up a little bit, but they're still pretty random. They might generally go one way, but not really enough to do anything. And of course, diamagnetic, they'll actually go the exact opposite way that you want them to, and will always repel. So these are some of the ideas that we looked at in grade 11. Okay. Now, one of the big things we looked at in grade 11, of course, was finding magnetic fields from wires. We talked about how way back when, hundreds of years ago, they found out that by accident that if they had a current going through a wire, it would produce a magnetic field that actually went around it in the shape of a circle. And we sort of mapped things out like this a little bit. And we would draw magnetic fields like dots and X's, something like this. So this magnetic field is going this way, where the magnetic field is coming towards you up on top. Here be going away from you. And this is when you guys did your basic right-hand rule number 1 when you guys were learning how to do this type of stuff. So this we had right-hand rule number 1, and you could actually find out which way the magnetic field was going around the wire. Remember from way back when, your thumb was the direction of the current, and then your fingers were the direction of the magnetic field going around the wire due to that current. And just from this alone, we looked at this a little bit. It's like the true source of magnetic fields. It wasn't magnets and domains, it was moving charge, because of course current is made up of moving charges. And even if you take that back to magnets, of course magnets and everything has moving charges with electrons orbiting and the protons are wiggling in the nucleus and stuff like that. So it's the electrons orbiting in certain ways and lining up in certain ways that actually makes things magnetic or not magnetic. So really, the true source of magnetic fields was moving charge. And it's really, really evident when you have wires with current going through them and producing magnetic fields. So another shape that you guys looked at last year quite a bit, we looked at things like solenoids and coils, where we have coils of wire and stuff like that. And we would draw things like, the current is going up like this. And we'd say, hey, which way is the magnetic field going? And this, again, we're using the right-hand rule, but we would often switch the function of the fingers and the thumb. So for a straight wire, thumb is the current, fingers are the direction of the magnetic field. But when you have a coil or a loop, what we often did last year in grade 11 is we said, flip the function of your fingers. So your fingers now more look like the coils of wire going on the coil, and your fingers show the current. So in the picture of the solenoid, if you guys remember solenoids from last year, your fingers are sort of going up and then curving around the back. If I do that, my thumb is pointing to the left. So since my thumb is pointing to the left, that means the magnetic field is coming out this way, and it would wrap around the other side like this, which means this would be the north end, and that would be the south end of the solenoid. So this is something else we looked at quite a bit in grade 11. Of course, if you want to go back to the grade 11 channel, your YouTube channel for that, you can watch some old videos on this type of stuff and remind yourself, or go look at your old notes from grade 11. And just a general review of the general structure of magnetic fields and how they work, and the domains and that type of stuff. These are all things that we looked at last year. We also did a little bit of work with wires and magnetic fields, where if you have a wire with current going through it, so the current's going through, and we have a magnetic field going across, something like this. And we said if you put a current through a wire, of course, it is also going to produce a magnetic field around it. And the interaction of those two magnetic fields would create a force. And last year we looked at a little bit of magnetic force was equal to BIL sine theta, where B is the magnetic field. You remember that's the symbol for magnetic field right there, for reasons that go back to actually, I believe, to Michael Faraday. Anyway, so we could calculate the forces on wires. And basically, you have a wire creating a magnetic field due to the current. The two magnetic fields would interact, and you get a force out of it. And of course, these forces, this is how electric motors work, and a whole bunch of other stuff. And these are the types of things that we looked at last year. So last year was mostly about the general nature of magnetic fields, the idea behind domains, how wires can create magnetic fields, and then we did a little bit at basic forces using what we call Bill sine theta last year a lot, calculating the force of wires and magnetic fields, that type of thing. In grade 12, it'll be a little bit different. We'll start looking at actually calculating the actual magnetic fields from the actual sources and then working with that instead. Sort of like the same way this year when you guys did gravity, we actually calculated the actual gravitational field and the forces it could actually produce. You guys calculate actual electric fields and the forces they can produce, and now we're going to start calculating magnetic fields and then looking at the forces that they can actually produce as well.